Hi folks, welcome to Ivy-GreGMAT GMAT Quant Intro Session Permutation and Combination. I am Arijit. Let's get started. Permutation and combination, it is basically about counting something. So the number of possibilities or the number of ways to arrange something, that's what is permutation all about. So let's see what kind of questions we come across in permutation and combination. It's like uh, with the questions we'll get a good hang of it. So how many different, say, how many uh, different, one second, say dinner combinations are possible. If we have one appetizer, uh, one main course, and say one dessert. This may be one kind of question. I mean, how many combinations are possible, or how many arrangements are possible, how many ways it can be done. Or the second type can be there are four people, there are four, and there are four chairs. So, how many arrangements? Uh, Another type may be seven people, but there are three chairs. How many arrangements? It can be four people to be chosen from a pack of 10 people to form a committee or a club or something like that. So how many possible combinations are there? Let's take some hard and fast examples so that will make it easier for us to understand. Example can be, say there are five people and there are five chairs. The possible number of arrangements we have to find out. Let the five people be A, B, C, D, and E. The five chairs can be 1, 2, 3, 4, and 5. Now, think about it. Forget the formulas and all, how it happens. Let's talk about that. It may so happen for the first chair, you have got all the five people here. So, for the first chair, chair number 1, you have got five options. For the second chair, because either of A, B, C, D, E have taken the first chair, you've got four options. For the third chair, you've got three options with you. For the fourth chair, you've got two options. And for the fifth chair, you're left with only one person, so on. So that means 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Or rather, we can say it's 5 factorial. Whenever something like this is represented, it is factorial 5, so it is 120. So 120 arrangements are possible. Say, example like it can start with E, taking it up here, and followed by B, followed by A, followed by C, or whatever. And innumerable, or rather, total 120 arrangements will be possible in this fashion. Let's take another example so as to understand it even better. Say There are 3 people. And there are 3 chairs. Why I am taking the similar kind of examples is that at least the basics are clear. So 3 people, let it be A, B, and C. 3 chairs may be numbered as 1, 2, and 3. You've got 3 options here, either A, B, or C. You've got 2 options here, and only one person will be left. So 1. So the total number of arrangements can be 3 into 1, 3 into 2 into 1. So 1 second, 3 into 2 into 1, 6. It is 3 factorial, which is 6. Clear? Let's see a longer way, how many options are ways it can be done. So if we do not have something like this, it can be A, B, C. That's one option. It can be B, A, C. It can be C, A, B. It can be A, C, B. It can be B, C, A. It can be C, B, A. These are the total number of arrangements, which is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. But we did it a longer way. But if we put it like this, it's fairly very simple. So the total number of arrangements for 3 people, if there are 3 chairs, is 6 ways. So these are the 6 ways. Clear? So it's actually, if you look at what you mean by factorial n, it's actually n multiplied by n minus 1 into n minus 2 till 1. So this is what is factorial n. So you count till the end till 1 and then multiply. So that's what it is. So it's basically we are counting. If there are 3 chairs, how many options can fill here, fill here, fill here, and we multiply. So that arises why we are multiplying, why not adding, etc., etc. So let's delve a bit further. We'll realize this is so important. Why this principle of multiplication? If there are 2 objects, 2 jobs, such that one of them can be completed by m ways, another by n ways, then the 2 jobs in succession can be completed by n multiplied by n ways. Let's take an example. In a class of 10 girls and 8 boys, a teacher has to select 1 girl and 1 boy. So how many ways she can make her selection? Remember, for 1 boy, the teacher has 8 options. For 1 girl, the teacher has 10 options. Clear? So for 1 boy, 1 girl, and 1 boy, it will be 8 into 10. So 80 options are there, or 80 ways in which this can be done. But the principle of addition, if there are 2 jobs such that one can be performed independently in m and n ways respectively, then either of the 2 jobs can be performed in m plus n ways. Let's see. Let's take an example. If in a class of 10 girls and 8 boys, 10 girls and 8 boys, same thing. The teacher has to select either a boy or a girl. How many ways she can make this selection? Well, again, for a boy, 8 options are there. For a girl, there are 10 options. So either 2 jobs. That means either a girl or a boy. That leads to 8 plus 10, 18 ways. So if I look at it in a plain vanilla way, our OR leads to addition and means you will have to multiply. Or means either this one or that one, and means both taken into consideration. So we multiply. Here we add. So with this basic understanding, we will go forward and see what is NPR. Well, we have come to this formula with a reason because it makes our life much easier. Permutation of NPR, each of the arrangements which can be made by taking some or all of the number of the things is called as permutation. So permutation is not necessarily 4 chairs, 4 people. It may be 4 chairs and it may be 15 people and 3 chairs. So that way. So the number of all permutation of n distinct things taken R at a time is NPR. Remember, we will definitely give a better look to this. In permutation, the order of the arrangement is taken into account. When the order is changed, a different permutation is obtained. So it may be AB and BA. You may say uh, 2 chairs. It's fine. This is, but in permutation, these are 2 ways. You'll come to combination where we consider only one. So the arrangement, the order of the arrangement is taken into account. So if a new arrangement comes, it becomes a new permutation. Let's understand further. I mean, that makes it more sense. So let's go to the chair example. 4 people, 4 chairs. Typical all example. All. 4 people, 4 chairs. A, B, C, and D. 4 chairs. 1, 2, 3, and 4. So 4 options here. 3 options are here. So chairs are like this. So we have got 2 options here and 1 here. So it leads to factorial 4, which means 4 multiplied by 3 multiplied by 2. It is 24 ways. Okay. So NPR, as we know it, here R is same as N, so it will lead to factorial N. So if all are taken into consideration, it's factorial N. So permutation or arrangement of N things when taking all at a time. Taking all at a time is factorial N. N things when all N are taken. Then this formula N factorial will give us the correct answer. But this is not the only case. It may be some at a time. So let's take some at a time example. So say there are 6 people. The question of sum. There are 6 people, but there are 4 chairs. So obviously some people will remain standing. So while let's arrange the chairs. Chair number 1, 2, 3, and 4. They are the 4 chairs. For filling the chair 1, you've got 6 options. For filling chair 2, you've got 5 options. For filling chair 3, you've got 4 options. For filling chair 4, you've got 3 options. So that makes it permutation is equal to 6 multiplied by 5, 4 multiplied by 3. If I put it in the form of a formula, it becomes NPR, which is factorial n. Now, since R is not n, or rather R is more than 1 but less than n, then it looks something like this. Factorial R n minus R factorial. Let's see. When some are taken into consideration, factorial n, here is 6 factorial divided by 6 minus 4, well, are n distinct things and R are taken, so 4 are taken, 4 or rather 4 chairs are there, factorial, which makes it 6 factorial by 2 factorial. So let's see how it happens. 6 into 5, 4, 3, 2, 1 divided by 2. Here is something which is similar to this. So our great formula of is actually a method of counting, which is like this. So here we did the typical counting method. Here we put a formula to make our life easier, to make counting easier, right? Let's take a bit of a different example. Okay, let's take a few more examples and try to understand how it is happening. So this one seems to be a good one. It is required to seat 4 women and 5 men in a row so that the women occupy the even places. How many such arrangements are possible? Okay, it's a bit of a different touch now. You've got 4 women and 5 men, and they are to sit in a row such that the women occupy the even places. So we have got total how many seats? 9 persons are there, or 9 places are there, and the even places are to be occupied by women. So it will be the second place, the fourth, the sixth, and the eighth. These are women. So if I take these two into account, so there are 4 women and there are 4 even places. So that makes it factorial 4 arrangements. There are 5 men and the remaining 5 places. So that makes it 5 factorial 5. So the total number of arrangements is factorial 4 multiplied by factorial 5, which is 24 into 120. So whatever its calculation, something like 80. So the twist is in this problem is nothing but the word like women occupy the even places. Nothing No problem, because there are 4 women and there are 4 places, 5 men, 5 places. So 4 women, 4 places, and 5 men and 5 places. So that makes it factorial 4, and this makes it factorial 5. Why we multiply? Because the sand. So 4 multiplied by factorial 5. Let's take another question. See. Okay, there are 3 men. 3 men have got 4 coats, 5 waistcoats, and 5 caps. In how many ways they can wear them? So there are 3 men who've got 4 coats. So how many arrangements are possible? Factorial 4 divided by factorial 4. 1 second. Minus 3 factorial. It makes it factorial 4, which is equal to 24. So 3 men again, they've got 5 waistcoats. So that makes it factorial 5 divided by 2, which is 5 into 4 into 3. That makes it 60. 3 men again, they've got 6 caps. So factorial 6 divided by 3. That makes it 6 into 5 into 4. That's 120. With this in mind, the total number of ways is 24 into 60 into 120. Why this multiplication? Because this is the thing. In how many ways can they wear them? Means they are taking everything into consideration. Let's see the next question. That makes it easier. Again, 3 men, 4 coats, 5 waistcoats, and 6 caps. In how many ways can they wear them? If wear any one type of them, there is a twist here. That means the previous thing, 3 men, 4 coats, makes it factorial 4, which is equal to 24. Or 3 men, 5 waistcoats, makes it factorial 5, 5 factorial 2, makes it 60 arrangements. Or 3 men having 6 caps can make it 120 ways. But here any one of them have to be chosen. So this one or this one or this one. So when there's an or question, then what do? We add. That means the arrangement of 4 coats or 5 waistcoats or 6 caps. This means the 24 plus 60 plus 120. This works out to 204. Let's go to the next one. In how many 4-digit numbers are there? Are there? Uh, how many 4-digit numbers are there with distinct digits? Well, let's make a 4-digit number. So that's 4-digit number means 1, 2, 3. Clear? And every number has to be distinct. That's what they are saying. So total number of, so n in this case is 10 because total numbers can be 0, 1, 2, 3, 4 till 9. So there are 10 digits, 10 numbers are there. And R is 4 because 4 distinct numbers are to be picked up, 4 digits are to be taken, 4. So the total arrangement may be factorial 10 by 10 minus 4 factorial, which makes it factorial by 6 factorial. But there's a twist here. Remember, if there are 4 numbers, and n distinct number, we have taken 0 into consideration. So we will have a certain number of numbers with 0 in the beginning, in the thousands place. Hence, those numbers have to be excluded because this number becomes a 3-digit number now. So 0, 5, 36 is not a 4-digit number, it's 536. So similarly, there may be combinations having 0 in the thousands place. So it may be 0 followed by x, y, and z. So I'll have to exclude all those numbers which are having this combination. So if this is the thing, and 0 is fixed, if this is fixed, for this we have got 9 digits. So 9 digits remaining to be rearranged, taking 3 at a time, obviously, because there are 3. So here n becomes 9 and r becomes 3. So the number of arrangement possible is 9 factorial by 9 minus 3 factorial. So that makes it 9 factorial by 6 factorial. So the total number of 4-digit numbers is 10 factorial by 6 factorial minus 9 factorial by 6 factorial. Great. Okay, let's go to the next one and see. Find the sum of all the numbers that can be found by the digits 2, 3, 4, and 5 taken all at a time. So this is a bit of a different question. So sum of all the numbers that can be found by these 4 numbers. So we have got fixed number of digits. So the total number of numbers is one second. Is factorial 4 because there are 4 numbers. So which makes it 24. Now to find the sum of these 24 numbers, what is asked is the sum of all the numbers. So sum of all the 24 numbers, we we have to find the sum of the digits at the units place, at the hundreds place, units plus the hundreds plus the thousands place. Then only the, the correct combination will happen. If that is the situation, let's see. 1, 2, 3, and 4. Step 1 can be, we can fix 2 here in the unit space. The remaining is factorial 3. So which is 6 ways. So the total number of digits in the units place, and if we keep swiping, if we take 3, then instead of 2, we can 3, we can fix 3, we can fix 4, we can fix 5. So the total numbers can be, the sum total can be 2 multiplied by 3 factorial. Here the sum is 2 multiplied by 3 factorial. While we keep swiping these, it can be this plus 3 multiplied by 3 factorial plus 4 multiplied by 3 factorial plus 5 multiplied by 3 factorial. Do a simple calculation, this will become 2 plus 3 plus 4 plus 5 multiplied by 3 factorial, which is 84. But remember, this is only for the unit space. This is only for the unit space. Now, what to do for the rest of the places? For the tens place, it is 84 into 10. For the hundreds place, 84 into 100. For the thousands place, it will be 84 into 1000. So let's add up 84,000 plus 8400 plus 840 plus 84. Whatever is the number is the sum of all the numbers formed by these 5 numbers. Okay, let's go to the next one. There are 6 periods in each working day of the school. In how many ways can one arrange 5 subjects such that each subject is allowed at least 1 period? Fairly simple question. Let's say there are 6 periods and there are 5 subjects. Having said that, so the 5 subjects are to be arranged in 6 periods. So it's 6p5. 5 subjects in 6 periods. So, but this continues fine, but there will be one remaining. One period left. One remaining period. What to do with that? So for that remaining period, you have got 5 subjects or 5 options you have got. Clear? So the total number of arrangements will be is equal to 6p5 into 5. The twist is here. Let's look into a bit of a different kind, which sometimes becomes a botheration, or that's what it is. Like, it's not necessary that the conditions are so straight. The permutation can be of any different things taken R at a time when a particular object is always included in the arrangement. It can be so possible that the particular object is never included. Let's take an example. Make all arrangements of the letter of the word pencil so that N and E are next to each other. So pencil, Pencil, 6 letters. While as for the first is concerned, N and E are next to each other. So it become, we'll take E and N together, CIL. We'll take it as a 5-letter word. So now the 5 letters can be arranged in a row in a 5p5 fashion. That makes it 5 factorial, which is 120 ways. Well, having said that, if N and E are always together, so where is the twist? Now you have got 1, 2, 3, 4, 5, 6, or rather only 5 ways because N and E are to be together. So let's see what best treatment we can give. N and E together. So we will have two arrangements here. It can be N E, it can be E N. If that is the case, for this we'll have 120 ways. For this we'll have 120 ways. Correct? So that means this actually becomes 5 factorial multiplied by 2 factorial, because these two letters can interchange. So it becomes 120 into 2, or rather 40 ways. Let's take another one. A tea party is arranged for 16 persons along two sides of a long table with 8 chairs on each side. Fair. This is okay. A tea party, 8 chairs on each side is okay. But the twist comes here. 4 persons wish to sit on one side and 2 persons on the other side. So how many arrangements are possible? Let's draw a table quickly. 2, 3, 4, 5, 6, 7, 8. Here also there are 8 chairs. Here also there are 8 chairs. So total 16 people are there. 8 chairs are there. If that is the case, but we have got 4 persons on one side and 2 persons on other side. So if there are 4 persons on one side, then 4 persons on one side. That makes it 8p 4 ways. Two persons on another side. We are arranging this set first. Then it is 8p2. with 4 plus 2, 8 people taken care of. Sorry, 4 plus 2, 6 people already taken care of. So there are 6 people already got seated. We have got 10 remaining out of the 16 people. So 16 minus 6, it makes it 10. So we'll have to set all these 10 people. Obviously, 10 places for 10 people, or rather 10 persons having 10 chairs or places to sit. So that makes it simple. 10 factorial. So the total number of arrangements possible is 8p4 multiplied by 8p2 multiplied by 10 factorial, whatever this number is. Okay. Let's go to the next one and see. Another variation, permutation of objects, not all distinct. We've got a formula here. The total number of permutation of n things when P are alike of one kind, Q are of another kind, and the remaining are distinct. So it is not necessary that they are all different. They may be the same. So let's take an example. How many words can you form with letters in the word Mississippi? We'll use this formula. How? Let's see. Mississippi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 words. So there are total 11 letters. And there are 4 S. I is there 4 times and P is there twice. So our formula here is factorial n divided by P factorial Q factorial. The P and Q are distinct ways, so it is 11 factorial divided by 4 factorial multiplied by 4 factorial multiplied by 2 factorial. Because there are, this is the n, the total letters. There are 4 S's, 4 I's, and 2 P's. So whatever is the number. Let's take the next word, apple. N is 1, 2, 3, 4, 5 letters. Here P is 2 times. A is once. L is once. And E is once. Going back to the formula, n factorial by P factorial, Q factorial. So 5 factorial divided by 2 factorial, 1 factorial, sorry, 1 factorial, 1 factorial, 1 factorial. Is nothing but 5 factorial by 2 factorial. Let's take the word India. INDIA. Total 5 letters. But I is repeated twice. I 2 times. So total ways can be factorial 5 by 2 factorial. Clear? Circular permutation. This is we consider one object as fixed, and the remaining objects are arranged in the as in the case of linear permutation arrangement. Like if x, y, z are there, or a, b, c, and x, y, z are there. If these are the people, so in a circular permutation, we fix one, and we'll rotate it here. So the total number of circular arrangements of n distinct objects is n minus 1. Let's see how we can do it. Arrange 5 persons around a circular table. 5 persons around a circular table. 5 minus 4 factorial is 4 factorial, which is 24. In how many of these arrangements will two particular persons sit next to each other? So here is a twist. So let's do it this way. This was 5 minus 4 factorial, which is 4 factorial, 24. But here is the twist. What is happening here? Two persons will sit next to each other. In this case, as we previously discussed, the two people will be taken as one. Step 1. Two persons who are sitting next to each other will be considered one. So we have 4 persons now. In circular arrangement. And the formula for this is 4 minus 1 factorial, which is equal to 3 factorial, which is 6 ways. And we have these two people who can sit in 2 ways. So 2 factorial, which is equal to 2. So the total number of arrangements will be 6 into 2. That is 12 ways. Okay, let's go to the next one. If 20 persons are invited for a party, in how many ways will two particular persons be seated on either side of the host? The question itself is having a twist. How? Can anybody identify this twist? If 20 persons are invited and two particular persons will be seated next on the either side of the host, so the total number is 20 plus one host. That makes it 21 people who are going to be seated. And here the two people will sit next to each other. So with 21 people here in total, two will sit next to each other. So if that is the situation here, we can fix these two people. So we'll be left with 19 people. Sorry. So two want to sit with each other, beside each other. So 19 remaining who need to sit in a circular way. So the total number of arrangements possible is 19 minus 1 factorial, which is 18 factorial. Now you have got two people who want to sit beside each other, who can sit in two fashions. Two people can. The person 1 followed by the host followed by the person 2. The other arrangement can be person 2 followed by the host followed by person 1. So there are two ways. So the total number of ways is 18 factorial multiplied by 2. Fine. So let's go to the next one. In how many ways can a party of 4 men and 4 women be seated in a circular table so that no two women are adjacent to each other? Let's make this arrangement 4 men, 4 women. So total 8. 1, 2, 3, 4, 5, 6, 7, and 8. Remember, in a circular table. So if men occupy like this, men, okay, and the women will be like this in a circular arrangement. So you may very well say it is factorial 4 multiplied by factorial 4. No, this is wrong. Because 4 men are seated in a circular table with a seat vacant between them. So if for men, the number of arrangements will be 4 minus 1 factorial, which is 3 factorial. And for the 4 vacant seats, that will be occupied by 4 people. For women, there are 4 vacant seats. So fill them up. 4 factorial. So the total number of ways is equal to 3 factorial multiplied by 4 factorial, which is 6 multiplied by 24. 144. Okay, now let's go to this thing which is called as NCR or combination. What is combination? See, to understand this, in combination, by definition, we find different ways of choosing R objects from N objects. While in permutation we find different ways of choosing R objects from N objects and the ways of arranging these R objects. So actually what is happening in combination, the ordering of the selected objects is immaterial, while in permutation ordering is essential. For example, AB and BA are same in combination, so we are going to treat as one combination, but is different in permutation. So ordering is essential in permutation. In combination, doesn't matter. Similarly, in each combination corresponding to many permutations, each combination corresponds to multiple permutations. For example, let's take this one: ABC, ACB, BCA, BAC, CBA, and all these are A, B, and C. Clear? Generally, we use the word arrangements for permutation and selections for combinations. Clean. Now, how this formula? Let's take on. NCR or selection combination is basically defined by a formula which looks something like this. Let's see. Say, suppose we have X, Y, and Z. These are the three objects. The number of permutations or arrangements taking two at a time will be, say, XY, YX, YZ, ZY, XZ, ZX. So there are 6 permutations. But if you look at them closely, in case of this is permutation, in case of combination, there will be XY, YZ, and XZ. 3 combination. Why? Because simple, XY and YZ are not different, are treated as same in case of combination. Or similarly, YZ and ZY are the same, or XZ and ZX are the same. So keeping that in mind, let's evaluate this formula. NCR is equal to NPR divided by factorial R, which is in a case factorial N divided by N minus R factorial divided by R factorial. That works out to N factorial divided by N minus R factorial multiplied by R factorial. Now it makes sense. So NCR is actually NPR divided by R factorial. So the formula translates to something like this. Let us see a few questions that will answer, or rather bolster our understanding or support whatever we have learned. From a class of 32 students, 4 are chosen for a competition. In how many ways can this be done? In a class of, let's change it, 6 students, 4 are chosen for a competition. So that makes it easier for us to calculate. So 6 people and 4 are, one second, selected. So this will be 6p4, which makes it 6 factorial divided by 6 minus 4 factorial multiplied by 4 factorial, which is 6 factorial divided by 4 factorial multiplied by 2 factorial. If you do this calculation, be a long one. So 6 multiplied by 5, 4, 3, 2, 1 divided by 4, 3, 2 multiplied by 2, 1. So if we do this here, this is 15. The combination is 15. But if you do a permutation and get rid of this, the number will be larger. Let's take another example. 3 gentlemen, 3 ladies are candidates for 2 vacancies. A voter has to vote for 2 candidates. In how many ways can one cast his or her vote? So 3 gentlemen and 3 ladies, and there are 2 vacancies. So in total, there are 6 candidates and there are 2 vacancies. Fair? So this is 6C 2. That's a combination. So it's like 6 factorial by 4 factorial multiplied by 2 factorial. So 6 into 5 divided by 2, 15. Okay. Out of 2 women and 5 men, a committee of 3 to be formed. In how many ways can it be formed if at least one woman is included? Okay. Committee of the total number of 2 women, 5 men are there, and a committee of 3 is to be formed. Fair? So what are we left with? The committee can look like 1 woman and 2 men. This may be one type, or maybe 2 women and 1 man. So this is 2C1 multiplied by 5C2 plus 2C2 multiplied by 5C1. So this is equal to 20 plus 5. Answer is 25. The next one, count the number of handshakes if there are 4 delegates and each shakes hand with the other one. So there are 4 delegates A, B, C, and D. What we are doing? We are going to count the number of handshakes. So uh, is it 4 multiplied by 3, which is equal to 12? No, this is not correct. As we are doubling the count, see, this man shakes hands with him, and him, and this person shakes hand with him. No, he only shakes hand with this and this person, because we have already, there was a handshake here, so we will not count this. So definitely it is a bit of a twist here. So we'll take 4C2, which is equal to 4 into 3 divided by 2 into 1 is equal to 6. Clear? So there are 6 ways. It can be like I was saying, it can be AB, AC, AD, followed by BC, BD, and for C it can be CT only. So these are the 6 ways. Okay. Okay, folks, that brings us to certain special cases like selection of any number of things out of interesting things. But here is a twist. Let's take into account this kind of a question where you can say something is different. Here, the number of ways a boy can or cannot eat sweets at a party out of 10 distinct sweets available at the party. So here, what can be done? Can eat, cannot eat. So you can see by our formula, if I go, it is 2 to the power 10. But why? So for each choice, he has got two options. He can eat, he may, he cannot eat. So there are two options. So n distinct things and you have two choices. So 2 into 2 into 2 into 2 into n. So which makes it 2 to the power n. Here the boy had two choices for 10 distinct sweets. So this n was 10. So 2 into 2 into 2, 10 times makes it 2 to the power 10. A bit of a variant, I can say. There's another way. N plus 1 is a selection when of any number of things out of n identical things. Let's see. Selection of any balls, any number of balls from 3 red balls. Well, the person concerned has got options like if number 1, 0 balls are selected. That's one option. Number 2 can be 1 ball selected. That's another option. Number 3 can be 2 balls selected. That's another option. Number 4, all the 3 balls selected. That's another option. So the total options are 3 plus 1, that's 4. Or rather, you can say 4 ways. So a bit of a variant just for your understanding sake. So thank you, folks. That brings us to the end of the introductory session of permutation and combination. Thank you.